For the law of cosines, we start with any old triangle with sides A, B, and C, where side A is across from angle A, side B is across from angle B, and side C is across from angle C. Then C squared is equal to A squared plus B squared, and we subtract out 2AB times the cosine of C. So I'm going to show you some patterns to help you remember this. You won't even have to think about the second two. If you think about the first one, understand the pattern, what's going on, you can use that to help you remember how to use this for any old triangle. So notice that C is the side that I'm squaring. It's all by itself on the side of the equal sign. And right across from it, I'm taking the cosine of C, which is across from side C. And the next one, B is the side that I'm squaring. It's right across from angle B, and that's the angle that I'm taking the cosine of. Side A is being squared. It's all by itself on this side of the equation, and directly across from it is what I'm taking the cosine of on this side. So this is always true. So that C squared and this C, they're right across from each other on the opposite side of the equation. The other sides, if I've already used C, then the other sides that are left over are A and B. And that's what's on the rest of this side of the equation, A squared plus B squared minus 2AB. And it's the same A and B that I'm adding together as squareds right there. It's the same thing with the next set. B squared, directly opposite the angle B, and the sides that are left over are A and C, and that's the same sides, that's minus 2AC. A directly across from angle A, the sides that are left over are B and C, those get squared, minus 2 times the same sides, B and C. So let's try this on a couple of examples after we do something else first. So first, let's take 90 degrees, substitute it in here and see what happens. So I'll have C squared equals A squared plus B squared minus 2 times A times B. If I were to stick 90 degrees in there, the cosine of 90 degrees is 0. Now if I multiply negative 2AB times 0, this whole thing disappears and I'm left with C squared equals A squared plus B squared, which is the Pythagorean theorem. So if C is 90, that makes a right triangle, and C squared is exactly equal to A squared plus B squared. So the law of cosines is actually a more general form of the Pythagorean theorem because it works on all triangles, not just right ones. In example 8, what I want to do is I want to solve this thing for C. In order to solve it for C, I have to get cosine C by itself, and then I'm going to take the inverse cosine. And you have to do this whenever you're solving for an angle measurement rather than the side measurement. So I want to keep it positive, so I'm going to add it to this side. Then I have to subtract the C squared over to this side, so I have this guy all by itself. So on the left I'll have 2AB times the cosine of C equals A squared plus B squared, and remember I had to subtract C squared. This is just a number I'm multiplying times C squared, or cosine of C, so to get rid of it I divide. Divide it by both sides. 2AB. That gets rid of it. That only gives me the cosine of C. To get C, I have to take the inverse. So C is equal to the inverse cosine of everything you see over here, A squared plus B squared minus C squared, all over 2AB. So this is how the steps that you would do in order to work backwards and find an angle measurement using the law of cosines rather than a side.